A block oscillating on a spring has a period of 2 seconds. What is the period if A, the block's mass is doubled? So this question is really easy. We have to find a formula that connects t, the period, to mass. We know that t and frequency's relation, it's an inverse relation. So period equals 1 over frequency, or vice versa, frequency equals 1 over t. We also know that omega, the angular frequency, equals 2 pi f. From the previous equation, we can also write omega equals 2 pi over t. We also know that omega equals a square root of k over m. K is a spring constant and m is our mass. Now we can merge these two equations to find a new equation where we can relate period to mass. We can write it like this: a square root of k over m equal 2 pi over t. Now let's take t to the other side. T equal 2 pi over a square root of k over m. Now we can also write it this way: t equal 2 pi times a square root of m over k. You see, we remove the fraction, the square root of k over m, from the denominator, and we just replaced k and m. Perfect. Now we have the equation that we were looking for, where we can relate mass to period. Now the question asks us what happens to t if we double the mass. We have to write, let's call this one T1 and let's call this one T2. In T2 the mass is doubled, so we can write it like this: 2 pi times a square root of 2m over k. Now in order to solve this problem, we must try to make the second equation looks like kind of the first one in order to cancel the same equations. I mean, like the same parts. So we can write it like this: t2 equals 2 pi a square root of 2, so we took these 2 out, times a square root of m over k. So here you see that a square root of m over k is exactly same as this one in our first equation. So let's cancel them out. Let's also cancel the 2 pi because it didn't change and it looks exactly like the first one. Okay, 2 pi. So the remaining is t2 equal a square root of 2, which is 1.414. In order to find, so this thing, this value shows us how much it increased. So in order to find the period, we just need to write the original period, which was 2 seconds, and times 1.4, which equals 2.8 seconds. So this is our new period. For part B, the value of a spring constant is quadrupled. That's exactly same thing. We can use the same equations because here the period is related to a spring constant. Let's call this again T1 and let's write the new equation: T2 equals 2 pi times a square root of m over 4k. We have to follow the same steps. We have to write the equation, or we can say we have to simplify the equation to cancel the same repetitive steps. So let's write it like this: t2 equal 2 pi times a square root of a quarter. We just took this quarter out, times a square root of m over k. We can eliminate these two factors which are same and the 2 pi. So the remaining, it remains only the square root of 4, which equals half. To find the period, the t2, we have to multiply the original period, which was 2 seconds, by half, which gives us 1 second. So if we quadruple the spring constant, the period becomes 1 second. Let's do the last part. The oscillation amplitude is doubled while mass and spring constant are unchanged. It doesn't change anything. It has no effects on our period because amplitude and period are not related at all. It means if you increase the amplitude 1,000 times, it won't change the period at all because they are not related. There is no equation connects amplitude to period.